Hi, in this video I'm gonna go over three things with you guys. The first one is sine squared theta plus cosine squared theta is equal to 1. I'm gonna show you guys how to get that. And then I'm gonna show you guys tangent theta is equal to sine theta over cosine theta. This might be a property that some of you guys already knew. Right? So for some of you guys, that might not be something new. Okay, for the third one, we are just trying to relate a straight line, the slope of a straight line specifically, with the tangent of the angle. Okay, so let's start with the first one. Alright, so at the bottom, over here, we have a unit circle. Right? We can see that the circle has a radius of 1 unit, and I have this blue straight line. Okay, and the straight line is intersecting the unit circle somewhere here, right? And it is also making the angle between the straight line and the positive x-axis. Let's just name that angle theta. Okay. In the previous video, we already talked about how to use trig functions, sine, cosine, to represent a point on the unit circle, right? So I want you guys to think about what is the coordinate of this point going to be. All right, pause the video, think about that. Okay, I hope your answer was cosine theta and sine theta. Right, we actually talked about this in the previous video. If you're not sure, feel free to rewatch that video again. Alright, so I'm just going to make this make this picture a little bit more visual friendly. Okay, so let's do that. Okay, now, so here I kind of have this right triangle over here. Right. Okay, so what I'm going to do now is kind of just copy that right triangle. Okay, kind of copy it, and alright, so this part is the radius of my unit circle, right? So let me use different color. So this is gonna be 1 unit long, right? One unit long. Now, how long is this gonna be? And also, sorry, before we do that, we need to. This is gonna be my angle theta, and this is my right triangle. What about this part? How long is that gonna be, right? And that is simply my x coordinate, so that would be cosine theta, right? This is simply cosine theta. Oops. Okay. Now, what about this side? This height, this vertical height over here, and that would be my sine theta, right? That is just sine theta. So I'm kind of looking at this triangle right here, this right triangle. Okay, I kind of just copy it over here. Alright, so now one of the first properties that we learned about right triangle back in middle school was the Pythagorean theorem, right? Or some people call it the Pythagoras theorem, right? Which says if I have a right triangle and I add the sum of the two, either the base or the height, the square of the base or the height is equal to the hypotenuse squared, right? So I can just apply Pythagorean theorem. I will have cosine theta squared plus sine theta squared, plus sine theta squared is equal to 1. Okay, and that's it, right? Now, when we are writing for trig functions, when we have exponents, we don't write them as such. Okay, we actually kind of put the exponent between the trig function and the angle. So cosine theta squared would actually look like that. Cosine squared theta, right? Plus sine squared theta. This is equal to 1. Okay, so we have just proved our first property over here. Okay, the first property is here. Okay, now let's look at the second property. Okay, so let's come back to our right triangle over here. Okay, our right triangle over here. Okay, so the second property says that tangent theta is equal to sine theta over cosine theta. Okay, and we already know SOHCAHTOA, right? SOHCAHTOA. Oh, oops. Let me change that. Okay, so SOHCAHTOA. So we are looking at TOA part, the TOA, right? Which is tangent is equal to opposite over adjacent, right? This is the TOA part. So if I look at this right triangle over here, let me just copy that. Okay. All right. So if I look at that, right triangle, and my angle is theta over here, right? This is my angle over here. This is theta. My opposite side is this. This is my opposite side, and my adjacent side is this side, right? So tangent of that angle, tangent of the angle theta, is equal to my opposite side, which is my sine theta, right? Sine theta. And my adjacent side is cosine theta. Alright, so that's the reason why. Okay, like I said, some of you guys might have already learned this before, but here is why. Okay. Alright, so the second one proved. Cool. Now let's look at the last one. Alright, let's look at the last one. Alright, so the last one is basically talking about the slope of a straight line, which is normally we use m to represent the slope. Some people call that the gradient. They mean the same thing. And we are going to try to figure out what is the slope of the straight line using a trig function. Okay, so let's see. So let's look at our picture over here. So we already know that the point over here we have an x coordinate of cosine theta and y coordinate of sine theta. Okay, so which means and also the line passes through the origin. So if I want to find the slope, if I want to find the slope, it is just basically rise over run. Right, so my slope is equal to rise over run. In this case, let's see what are they. So my run, let's start with run first. My run will be that much. I'm going to the right, and how much am I going to the right? Cosine theta, right? So that's going to be my run. My cosine theta is my run. Now, after I go to the right, I have to go up. How much am I going up? I'm going up sine theta, right? So that would be my rise. And hey, sine theta over cosine theta, when we talked about the second property, this is simply my tangent theta, right? This is simply my tangent theta. Tangent theta, right? We found this when we were trying to find to prove property 2. Right? So what we're saying here is that when I take the tangent value of an angle that passes through the origin and intersects the unit circle, the angle that the line makes with the x-axis, the positive x-axis, when I take the tangent value of that, and that will give me the slope of the line. Okay, and that's it. All right, that's it. I hope you guys took down some notes. These 3 properties, they are pretty important, and they are the fundamentals of many more trig properties. Right? If you have any questions, bring them to class, and I'll see you in the next video, or I'll see you in class. Bye.